record. Problem number 2. A surveyor measured the angles of elevation of a mountain's peak from 2 observation points in the ground level. We start annotating. The angle of elevation from angle A, from this angle, is 47 degrees. Remember that we will draw here an altitude for the height of the mountain. While the angle of elevation from point B is 34 degrees. The 2 observation points are situated west of the mountain, and they are 200 meters apart. Approximately, how high is the mountain? Let me draw it this one first. You see the other triangle? This triangle. That's an oblique, right? BA. This one is 34 degrees, and this one has a pair. Now remember that from this angle of elevation to this point, we are forming a linear pair. Therefore, the sum is 180. So if this angle, angle A, is 47 degrees, the other one, this one, its linear pair will be 180 minus 33. Minus 47, sorry. So it becomes 133 degrees. So once we will draw, this new angle A now is 133 degrees. Now what are we going to solve next? We need to solve for this one, for this side. And this is side B. So let's first solve for side B. But here the given is 200 meters and we still have one angle. So to solve for angle C, we need to subtract it from 180. So it becomes 180 minus 34 minus the linear pair, 133. So angle C will be equal to, what's the measure of angle C? 13 degrees. That's the top angle. 13 degrees there. So our complete set now is C. Sine C over small c. And we're looking for B, right? Side B. So sine B over B. You have sine 13 over C, that's 200, equals sine B 34 over small b. Let's cross multiply. B sine 13 equals 200 sine 34. If you notice in the module, I placed the sides first. Here, I'll place the angle first. They will get the same answer as long as you are consistent. If sides are on top, they will be on top. If all angles are on top, be sure they are also uniform. So what is now the answer for B? We have 200 sine 34 over sine 13. The answer is 497.17. So this one is 497.17. Next, let's draw our right triangle now. This is the mountain, okay? The height of the mountain. So we have 497.17. This is A and C. This is the angle of elevation is 45 degrees. Right angle. We're looking for the X. This is a right angle, so you need to use your SOHCAHTOA CHOSHAKAO, okay? Now, based on angle A, can anyone tell me what is this 497.17? Is it the opposite, the hypotenuse, or the adjacent?
Hypotenuse.
Very good. That is our hypotenuse, 497.17. What are we looking for? What is the x? Opposite, adjacent, or hypotenuse?
Opposite.
Very good. The x is our opposite. So what function are we going to use? What function has both opposite and hypotenuse?
Sine.
Very good. See, let me write SOHCAHTOA. You see, sine has both opposite and hypotenuse. So for our SOH, we'll write sine 47 equals opposite x over hypotenuse 497.17. Cross multiply them. So our x will be equal to 497.17 times sine 47. There. It's approximately 363.61. Do not forget your unit of measure. The given is in meter. And it's asking you to round your answer to the nearest meter. So the answer will be 364 meters. The mountain is 364 meters high. Any questions? Give me a thumbs up if you're ready to move to the last problem. And then I could not see the thumbs up. Okay, very good. Let's go to the last problem. Airplane A is flying directly toward the airport, which is 20 miles away. So I've drawn here, airplane A to the airport is 20 miles. The pilot notices plane B 45 degrees to her right. So from plane A, you draw an angle 45 degrees to the right. Airplane B is also flying directly toward the airport. The pilot of airplane B calculates that airplane A is 50 degrees to his left. Based on the information, how far is airplane B from the airport? Now, why is it important for us to calculate things like this? You know what? In the aviation, you see there are many planes on top. So they need to fly at a certain altitude, a certain height, and they need to descend at a certain angle so that even the gap of their landing will just be minutes. They will not collide with each other because they are flying at different heights and in different speed also, and in different angles. So we are asking, how far is airplane B from the airport? Let's name them first. What's the given in the angles? What's the measure of angle A?
45.
45. What's the measure of angle B?
50.
50. Very good. What's the measure of angle C? What's the measure of angle C?
85.
85. Now, what is this 20 miles here? What side?
Side B.
Very good. 20 miles. What side are we looking?
Side A.
Good. We're looking for side A. So you could say A is the distance from plane B to the airport. So let's write our complete set first. Sine B over side B equals sine A over side A. Let's substitute. Sine 50 degrees over 20 miles is equal to sine 45 over angle A. Cross multiply. You have A sine 50 equals 20 sine 45. Divide both sides by sine 50. What's now the answer for our A?
miles.
18.46. Do not forget the unit of measure, mile.
Miles.
Verify it in our calculator. 20 sine 45 over sine 50. There. It's approximately 18.46 miles. Any questions? Give me a thumbs